Hi everyone. Today what we're going to go through, you can see the title up on the top. I'm just going to highlight it here. What we're going to deal with is our properties of our quadratic functions. So we're going to look at the same parabolas that we've spent a couple days reviewing. But what we're going to do is we're going to knock out all of those key properties for each parabola. So what you'll see on your lesson handout is we've got a big chart that includes finding all of those properties for those four parabolas I've given you the equations for. What I want to do is I want to walk through each one of those. At times, or a lot of the time, I'm going to ask you to go through and plug in what you know, but I want to walk through the process of dealing with these equations, the form that the function was given to you, and how that can shape which properties tend to be a little easier to find versus others. So what we're going to do is we're going to look at specifically A, then B, then C, and so on in and of itself. Okay, let's jump right in. Okay, so what you see is I've just taken column A and I've just isolated it. And so I'm just isolating it so that we have a bunch of room over here where we can go through and we can just do some work. Because to find some of these properties, we're going to have to do a little bit of algebra. Now, what I'm also going to do is I'm just going to go through and I'm going to try, or I will, go through and kind of color code some things. So as we start to work our way down that set of properties, I'm going to try to find up in my original equation, and you'll see that equation right up in there. I'm going to highlight specific components to that or find certain properties within that, and we're going to find all the other properties in our table kind of based on that same color coding system. I think it's going to help you when you look back at this as we progress. So I'm just going to get rid of all of those highlights. Let's jump in and get going. So the first thing I notice is my equation has been given in vertex form. And so perhaps I'm going to actually deal with that vertex first. So I'm going to put my vertex information, the fact that my vertex is at 1, -4, everything I have in blue. So I will notice then that my vertex is at 1, -4. I've got brackets around it to show that it's a point. And now all the other things. Well, my vertex doesn't tell me anything about the direction. It doesn't tell me anything about the shape. It does give me information about my axis of symmetry. And I know that my axis of symmetry is a vertical line, so it starts with x equals. You must have x equals. And I know that it passes through the x coordinate of my vertex. So x equals 1 is my axis of symmetry. I need you to know that if you simply jotted down 1, you're wrong. You will not receive any marks for that. What you're telling me there is a value when the axis of symmetry is a line. So you make sure that we state it as an equation. Okay, it doesn't tell me anything about whether it's a max or a min, and it doesn't tell me, oh, wait a second, we get down to our max or min value. So don't chop off the max min too quickly. Notice this one's asking me about the value. And I know that on that parabola, if my vertex was at 1, -4, if my parabola is opening up, then my minimum value is the y-coordinate at my vertex. If my parabola was opening down, then my y-coordinate is the maximum value of my function. So I actually have been given that answer within, -4, within the coordinates of my vertex. Okay, I can get rid of that. My domain doesn't really tell me anything about my domain. It does tell me something about my range. Since my vertex is either going to act as a maximum to my parabola or a minimum to my parabola, I know that my y values have to always be to one side of -4. So I can argue that I could at least jot in the y and the -4. I just don't know right now, is it greater thans or less thans? So I now take a peek. My vertex does not give me information about my y-intercept, nor does it about my x-intercepts. So I'm going to get rid of all of those little slashes I put down in my table. And my vertex gives me all of that information. So I can get rid of that blue and we are good. Okay, where next? Well, the other piece of information that I was given in my problem is that 3 out in front. So there's my a value. So I'm just going to jot down that a value of 3. Now, what does that a value tell me? So I'm going to put everything in my chart that would relate to that 3. Okay, my a value being 3 definitely gives me my direction. Because it's a positive value, then I know my parabola is opening up. That 3 also gives me some other information with regards to the shape. Now, I need to be very clear, very, very clear, that when we ask you the shape of that function and you want to write in parabola, then I'm going to write, well, duh, and give you 0. Because we know that it's a parabola. We're not asking what shape is the graph from the standpoint of what type of function. What we're asking is one of two options. Is it steeper than your normal parabola, or is it flatter? Now, we could also ask for a normal statement, and you can just say, well, we haven't done anything to change the steepness of that graph. But really what we're looking at is, how has the shape been changed from your base function? So, because we see that 3, then we know that that is a vertical stretch by a factor of 3. That is going to make my graph steeper. Okay, we keep going down. I have a max or min, and yes, that 3 does tell me that since my parabola opens up, there is no top to it, but there is a bottom. And so therefore, we have a minimum. And I keep scrolling my way down. It doesn't give me any information about domain, and it doesn't tell me anything about y-intercept or x-intercepts. Now, I do want to maybe kind of piece something together with respect to the x-intercept part. And this is going to be something for us that if we start to combine some properties, we may be able to figure something out. So I'm just going to get rid of those red slashes. Now what we're going to do is we're going to knock out the next 3 properties, the 3 that are missing. Well, my domain is nice and easy. For every parabola, my domain is x is an element of the real numbers. X can be anything in that equation because I could sub in any x value I want and calculate a y value. You know that x is an element of the real numbers because every parabola gets wider and wider and wider as it's extended. Eventually, it exists for every x value. So I'm going to get rid of those beautiful parabolas that I just sketched over there. Let's come in on the y-intercept. So we are now going to go through and we are going to find a y-intercept. Well, I know that to find a y-intercept means that I could sub in x equals 0. I cannot read the y-intercept from that equation because I'm in vertex form, so I've got to calculate it. Well, it's a pretty quick calculation. Just make sure that we don't do something silly and say, well, 3 times negative, okay, so -1 squared is -1, and so on. So, as long as we're good that we don't have a hiccup there, -1 squared is 1. And we come in on a y-intercept of -1. Okay. Now I want to come to that x-intercepts, that last one in that list, because I would strongly recommend that you consider something before you get going. I could completely just do this. Okay, to find my x-intercept means y equals 0. And then we just keep going through and trying. I think what I would do if I were you is it's worthwhile to take, I don't know, 5 seconds, 10 seconds. Right now it might be 10 seconds or closer to, but with a little consideration, I think it becomes very quick for us. Think about your parabola and its position right now, and I'm just going to draw a quick sketch. There's my axes, and what I've found in blue was that my vertex was at 1, -4, and I found that it opened up in red. So the first thing I'm going to look at is, does this parabola even have x-intercepts? And we should be able to see that yes, if I extend it, then I will cross my x-axis somewhere. And so now I'm going to go ahead and find it. Now, you might be looking at that going, well, duh, of course it was going to. And I just want you to notice one quick thing. Let's say that I had a case where my vertex was at 1, -4, but now it was opening down. Well, can we see that clearly that parabola is not going to go and cross the x-axis? It has to do this, which means it's going farther away from the x-axis. So I would have no x-intercepts. I could right now write in my table that there are none. And I don't even have to spend any time algebraically trying to go on the hunt for them. That I think if you take a couple moments and you just look, where is the location of my vertex? I notice that it's below the x-axis. And so as soon as I see, I don't care where it is, but if it's below and opening up, then I know I have x-intercepts. If my vertex was above the x-axis and opening down, well, then I know I have x-intercepts. That to just consider that combination of properties for a moment can save you a bunch of time. Okay, I want to go back because I just noticed in our table that I missed one other thing that I can fit in because of that red. I want you to look down to your range. And I think because I jotted down so much blue, I overlooked it. Because my parabola is opening up, I know that my range has to be y values that are greater than or equal to -4. Okay, now that we got that fixed up, let's go through and find our x-intercepts. So we've determined that we will have x-intercepts, so that's why I'm going to go through and find them. So I know that I can make my y value equal to 0, and now I have an equation to solve. Now, I want to walk through this one because this one is going to cause a little bit of an extra wrinkle. And I want to give you a little bit of advice as to what you need to do to solve. I'm going to go through the process of isolating what we had talked about previously of, well, when I see that my x value is in one spot, I'm just going to get it all by itself. And so I'm going to get rid of that 4 and now divide out my 3. Now, I'm going to put a big star beside that line because I'm going to tell you that as soon as I see that, getting rid of the 4, dividing out a 3, and seeing that that becomes a fraction that I can't reduce, I know that I'm going to have a process I'm going to need to go through. So I'm going to just get rid of those last arrows. Oh, shoot, I just got rid of everything. Okay, I'm going to leave those. I'm just going to jot back in what we have at the top. To find my x-intercepts, I made my y value 0. And now I had that. Sorry. That once we get to that point, I know I'm going to have a process I'm going to go through. Okay, we are going to take this in its bits, and we're going to see kind of how we accumulate some of our knowledge. Okay, take a look at that line that's got the star on it. Now to get that x all by itself, I've got to get rid of my squared. So I'm going to take the square root. When I take the square root, I know I'm going to have two answers, my plus or my minus. I can simplify the left side because to take the square root means that I take the square root. Yikes. That's the square root of 4 of the top and the bottom. So when I see square root of a fraction, I need to take the square root of the top and the bottom. Now, in all likelihood, you're just going to calculate whatever you can. So we're going to get plus or minus 2. I can't calculate root 3. And there we go. Now, I should say that I think we should be comfortable to go from the starred line straight down to that line. By no means would I need to see the lines in between. However, now that we get to that last line, I think you can see a problem with it. Think back to us reducing radicals and simplifying. I have a radical on my denominator, and I know that proper form means I can't have a radical on the bottom. I'm going to have to rationalize. So my next line then is going to be me taking that plus or minus 2 over root 3 and now multiplying top and bottom both by root 3. That's going to enable me to simplify the top to 2 root 3, my denominator 3. And now my fraction's rationalized. The only thing left is to get rid of that minus 1, so I'm going to have a plus 1. I want you to notice how careful I was to ensure that I didn't sloppily write a big fraction line here, because that 1 isn't a part of that fraction. So I'm going to get rid of that line, and now we notice we have to get a common denominator. I can finish that off. And there are my simplified x-intercepts. That is quite the process. So I'm going to just jot that in my table right now, that I have 3 plus or minus 2 root 3 thirds as my x-intercepts. Ugly x-intercepts. Well, a couple things. First off, look at that starred line, and you can maybe see why I could tell that I was going to have to rationalize as soon as I had a fraction that didn't reduce. I can see I'm going to have to rationalize because as soon as I take the square root, I'm going to have a square root of something on the bottom. Now, for me to be a little more specific, as soon as I saw that that denominator was not a perfect square, that's when I knew I was going to rationalize. But in a lot of cases, you might just get rid of the 4, divide out the 3, go fraction and go, ugh, I don't know. I know my personal mistakes may be during that rationalizing process. You know what? I think I would be better to just expand my brackets, collect like terms, and use quadratic formula to solve for my x-intercepts. Okay, something to keep in mind. I don't care how you solve for it. Our job now is to be perfect. Okay, there's us just going through column A. And yes, that took a while to get through everything. However, I think the time we spent to talk about A is going to speed up so much more of what we do afterwards. Okay, now let's jump into problem B, or column B. So let's look at what we've got in column B. You take a peek at that, you notice we were given it in standard form. I think we should be good to be able to go through and fill in a bunch of stuff right now. We've got enough in our disposal to say that I recognize there's my A value, and we can fill in everything in that table that we know just based on that A value. Okay, I want you to pause it now and go through and fill in everything. Go quickly. Okay, we're back. So I see that that A value is a negative 2/3. That negative tells me that my direction is down. Because it's a value that's less than 1, I know that that means I have a flatter parabola. I keep going all the way down. I notice that since it's opening down, oops, sorry, I wrote that in the wrong box. I have a maximum, and I do know within my range that my y values now have to be less than or equal to because it's opening down. Okay, I can default and fill in my domain. That's no big deal. Okay, everything else I'm missing is because I don't have the vertex, or at least a bunch of other stuff that's missing. I do also, though, because I'm written in standard form, I can read my y-intercept directly from the equation. So I have a y-intercept at 5. Please do not tell me 0, 5. 0, 5 is redundant. Because you've been asked for the y-intercept, that implies that your x-coordinate is 0. Do not restate it. It's bad form. So just tell me 5. That is the y value at the axis. Okay, I've got a bunch of other stuff I've got to do. Okay, let's go on the hunt. So I'm missing my vertex. I think that this is probably one that we're going to go through and try to find that vertex. And I think for us, probably a good way to do it would be to find my maximum value. I know that my x value is negative b over 2a. So I know that my x is going to be a positive 8 over 2 times negative 2/3. So I've got a little bit of work to do. There's my 8 over a negative 4/3. And now if I flip and multiply that, then that's going to be an 8 times a 3 over negative 4. And that's going to end up being a 24 divided by 4, negative 6. So I know my x-coordinate at negative 6. I should be good to finish this thing off for the most part. So what I want you to do now is go ahead and find the y-coordinate, your vertex, and then fill in your chart for everything you can find based on that. Okay, pause it now. Okay, we're back. So I'm coming up to the very top. We should have subbed in x equals 6. Sorry, negative 6. Back in. So I've got my y equals negative 2/3 times a 36 minus, so plus 48 plus 5. I think that's probably a pretty good first line. I can do a little cross-reducing here. If I divide out that 3, I get a 12. And so I do get a little confirmation. There's a negative 24 and my 48. Half the first, double the second, that sort of thing. And I'm going to add on, I might even find it easier to just keep that way because I'm going to get a 24 plus 5, which is a 29. So I'm going to go right back to my chart then because I know that my vertex is at negative 6, 29. Okay, we should get some confirmation as we go. Everyone has x equals negative 6 as my axis of symmetry. I now know that my maximum value, so my maximum value is 29. And I'm going to do a quick consideration. Oh, sorry, I also know my range is less than 29. Man, I got to remember to fill that in. Okay, I'm going to do a quick consideration. Right now, I know my graph has a vertex that's above the x-axis because the y-coordinate is 29, and it's opening down. I know that we're going to cross that x-axis, so I'm going to go and spend time to find my x-intercepts. So to find my x-intercept, that means my y value is 0. Now, a couple things in this instance. You do have a vertex-formed equation now. You just haven't written it. That perhaps we say, well, now that I know my vertex, then there's my vertex with my shape. Maybe I want to use that as my form of my equation. I would almost universally say don't. My reason for it really has nothing to do with algebraic or with your algebra. It's really that, look at all the blue up there. Can you guarantee that you are perfect and you never make a mistake in doing that? Keep in mind, if you made a mistake anywhere in that blue, then your green's going to be wrong. That my suggestion to you would be, let's go back and let's use the function as it was given to you. I have no idea what I'm writing here. That I am going to find my x-intercepts by making my y value of 0, and I'm going to use the given form of that equation. Okay, now we take a look at that fraction, and my suggestion to you would be, if you don't like having that fraction in there, get rid of it. So maybe what I'm going to do is I'm going to multiply out my 3. Well, the other thing that I don't like is I don't like having a negative leading coefficient. And so now that it's an equation, I'm going to divide both sides by -1. I think I'm going to have some people that could have done both of those steps in one. Okay, here's where we come to a decision. How fast are you at factoring? And if we take too long to look to check factors, would we have just been faster to go through and use quadratic formula anyway? So maybe you're super fast in factoring and you're going, okay, two numbers to multiply to give 2, 5 and 3, 6 and 5, nope. 3 and 5, 10 and 3, nope. 15 and 1, not even close. 1 and 15, not even, okay, doesn't factor. And then you work your way through. It might be worthwhile to try that. Or we just go, okay, I'm going to go through and use my quadratic formula. So I got -24 plus or minus the square root. Well, I've got 24 squared. I don't think that we know that one. We're probably pushing buttons. Now I have my -4 times a times c, so I'm minus, my c value is negative, so I know I've got a plus. 8 times 15, there's your 120, all over 4. Okay, now we can put some stuff together. I don't need that x equals. So I have my -24 plus or minus the square root of 696 all over 4. And here's where I'm going to spend some time to see, can I reduce that thing? So I'm looking at it and I'm going, it's an even number. I know 2 goes in. I do a quick addition and I notice those add up to 21. So I know 3 goes in. I know 6 goes in evenly for sure. If I divide that by 6, then I'm going to get a 1 and another 1, 116. Well, I take a look at 116 and I'm pretty confident to know 4 goes in because 4 goes into 100 evenly and 4 goes into 16 evenly. And so if I take 116 and I divide it by 4, 100 divided by 4 is 25, 16 divided by 4 is 4, put those together, 29. There is my factor tree. There's no point in me factoring 6 further because 29 is a prime number. I'm not going to get any squares. So that is going to give me -24 plus or minus 2 root. Now I got to put the 6 and the 29 back together. So 6 times 20 is 120. 6 times 9 is 54. That's going to give me 174 all over 4. And now I notice that I have a common factor of 2 in there. I can divide that out, and I get down to those beautiful looking roots of negative 12 plus or minus root 174 halves. There are my x-intercepts. And there we go. So hopefully we matched up and we did pretty well working our way through. I'm hoping that we were pretty good to nail out the red and nail out the blue. And then we could see what we could do to go through and deal with the green. Okay, let's keep it going with another example. Okay, so let's take a look at C. Now, the thing that always drives me nuts is someone might have some difficulty with C, even though it should look pretty simple. Okay, what I'd like you to do, let's try to knock out as much as we can in that table. So, without doing any algebra, I want you to fill in whatever you can in that table. Okay, you're not allowed to do any algebra. Just read the equation and interpret. Okay, pause it now. Okay, we're back. So, I'm hoping we look and we see we've got a positive value out in front. So we know that we're opening up. It's a 1, so we have a normal shape. Since it's opening up, then I know I have a minimum. And that means that I know my range is y has to be greater than or equal to. Okay, now I don't know my vertex. So I would have expected a bunch of people to say, for your minimum value, I'm just going to tackle this one a little different, and we'll get some stuff that matches up in the end. Because my function is a binomial, and specifically, it's the squared and the single x term, that I'm going to find my x-intercepts right now. Because when I let in that y equals 0, I know that I'll be able to pull out a common factor of x. So when I solve for my x-intercepts, I get x equals 0 or x equals negative 4. That helps me right off the bat. Now, I don't even need to see this in terms of your solution, but I know that my axis of symmetry has to be right in the middle. I know that it has to be at x equals negative 2. Now, we could go back to our sketching kind of approach and say, well, I know my axis of symmetry has to be me adding those things together, cutting it in half. However, I would argue to you that because we can just see those points, like almost picturing our parabola at 0 and negative 4, we can see that our axis of symmetry has to be at x equals negative 2. So maybe I go straight to x equals negative 2. Okay, I think by getting down to there, we should be good to jump in and deal with some algebra now. So I want you to finish it off. You go through and you find stuff any way you like and finish off that table. Okay, pause it now. Okay, we're back. So to finish that one off, perhaps I'm now going to take my x equals negative 2 and sub it back into my original. Negative 2 squared is 4. 4 times negative 2. I now know my vertex has to be at negative 2, negative 4. Okay, I know I'm down here. My parabola is opening up. So I do know that these two x-intercepts make sense. Okay, what do I now know? Well, I know my minimum value is at negative 4. I always know my domain. My range then has to be greater than or equal to negative 4. And what always puzzles me is we clearly have the y-intercept. It's at 0. First off, it's at the origin. So that's our x-intercept and our y-intercept. But also, in standard form, I don't see a constant on at the end. I know my y-intercept is at the origin. Okay, Hopefully we matched up on that one, and we've got one more to go. Okay, I'm going to leave you with D, and I want you to work your way through D start to finish. So when you come back, you should have a completed chart or table with everything filled in for D, or you got absolutely stumped, and even looking back at the previous three problems still didn't help, and you needed to see some solution to D. Okay, hopefully we're coming back with the former. We've got D finished, and now it's just a matter of process. Okay, pause it now. Okay, we're back. So let's say this was a speed thing for me. And I was going through and I was saying, okay, I want to be able to find that. Well then, quickly, y-intercept is 1 automatically, and I can do everything that pertains to opening up. However, I'm going to argue to you that like maybe you start to see this process and you go like, well, I know that I'm going to need the vertex. I know I'm going to have to find some things. Okay, I'm just going to find those right off the bat. Sure. I would fight the urge for that. I really would. Because it might mean that you're going to do work that you don't need to do. So let's keep going with what I see and then start to fill in stuff and then see what you're missing and go on the hunt. I honestly think it's the best way to tackle the problem, even though there appears to be some jumping around. Okay, I've got my 5 out in front. It's positive, so I'm opening up. It's greater than 1, so it's a steeper parabola. That means I have a minimum because it's opening up. My domain is pretty automatic anyway. Maybe you keep doing what I was doing and you forget to fill in that range. Okay, so then I'll hold off on the range so I don't goof up. My y-intercept is 1. Okay, I do need to find my vertex. So for my minimum value, I know that my vertex has to be at negative b over 2a. Reduce my fraction. I know I've got to be at negative 1/5. So that means that I'm going to have to sub x equals negative 1/5 back into my function. Calculate that to positive 1/25 minus 2/5 plus 1. We should love to see that because that 5 is going to reduce, and it actually makes our work relatively straightforward. My two fractions come together to give me a negative 1/5. Change my 1 into fifths is going to be 5. And I get the coordinates of my vertex at negative 1/5, 4/5. Okay, well, we know that that allows us to fill in our axis of symmetry, our minimum value, and now we can complete our range in detail. Since it's a minimum, I know I've got to be greater than or equal to, and there's the y coordinate of my vertex. I wrote that really big. There we go. Okay, now I go through and find my x-intercepts. So to find my x-intercept, and I'm going to argue to you that if you just did that, we've really put the blinders on. Remember what we do. It's worth the few seconds. My y-coordinate on my vertex is positive, so it means that I'm up above the x-axis somewhere. Who cares? But I'm above. And my direction of opening has me going up. I can tell very quickly that I have no x-intercepts. So my x-intercepts are none without doing any work. Now, if I was to be a little cumulative, maybe I have some people that use your good old discriminant. And you calculate and you say, okay, so b squared is 4 minus 4 times 5 times 1. So that's 4 minus 20. That's negative 16. Wait a second. My discriminant is negative. So therefore, no roots. Or I guess, suppose you went through and you dealt with quadratic formula, But then you would have had to work all your way down to get that negative underneath the root. Seriously, take the few seconds to consider location of vertex, direction of opening, to see whether it's worth your while doing any of that calculation. Okay, hopefully we matched up, and hopefully that gives you a good gauge as to whether we're comfortable to go through and fill in all of those properties. You will be responsible for being able to identify all the properties of that parabola. So let's make sure that we're comfortable to do it and do it relatively quickly. Okay, jump in and get some practice. You should be good. Good luck.